Hi everybody, welcome back to this new WeeW episode for the STM32F1 tutorial, and we're still working on the I2C communication, where this time we're going to take a look on how reading data using the I2C communication way from the BNO055, which is an EMU or inertial measurement unit. So by the end of this video you will be able to set up and connect this BNO055 with an OLED screen, and you will be able also to display the Euler angle, the three of them, on this OLED, so you can see and on real time the position of this test board. So for example, if I take the roll and I keep moving to this side, you can see the roll will be increasing the more I move it to this way, and it will be decreasing the more I push it here. So stay tuned and let's build it together. Before jumping to the video, let me take the moment and thank everyone for their support. I will keep doing my best to provide this quality content. So as usual, to support the channel, you can give us a thumbs up, make a comment, or subscribe and stay tuned. As usual, the code is available on GitHub and the link is in the description below. The code that we are going to use will be the C, and finally this level is a little bit advanced. But for those who would like to know more about the BNO055 instead of the also the STM32F1, they can take a look at the first part, where we are going to give a small introduction and also some tricks that you can have with some models. And finally, if you would like to see the logic, there's a lot of way of doing it, so please stay tuned. Okay, so for the hardware, we are going to use as usual our aka Blue Pill or the STM32F1, also this time the BNO055, and we are going to add our OLED screen SSD 1306, which we will be using to show the output data from the BNO. So let's take a look to the tutorial. So first of all, we need to get a little bit knowledge about the BNO055, and then let's have a small introduction, a really small introduction to the EMU and the desired output that we are going to seek. After that, so we are having a quick look on the BNO055 connection and setup. This is also related to the board that we are going to use for the BNO. Then we are going to start coding, and we are going to code the transmit and receive, this is the receive function. After that, we are going to initialize and create the BNO Euler function, where we are going to get the angles. Finally, we have a wrap up and we will visualize the data. Okay, so about the BNO. So the BNO is made by Bosch, and it has a fused sensor data. Please keep fused in mind, because it's very important information. It can give you an output of quaternion, Euler angle, and this is what we would like, the rotation vectors, linear acceleration, and also the gravity, which is really fantastic. Also, you can have the headings too, so which is really related to the compass of the data. And it does have 3 sensors inside one device, which is really wonderful, because some of other small boards, they do have the 3 different sensors and you have to make the computation. It does have also several digital interface. It has the HID I2C, which is if you would like to connect with a PC, an I2C communication tool, and also Uart. Finally, the voltage operation can be from 1.7 to 3.6, which is really perfect for our STM32F1. And this is a picture coming from the datasheet of this BNO055. You do see the 3 magnetometer, accelerometer, and gyroscope. All of them go, and there is a data fusion, so that creates and give you immediately the desired output. So you don't need any extra computation from the microcontroller, and you can get it immediately, which is really wonderful and quite useful for as an application. So you don't have to spend the more energy at your microcontroller to get this information. Okay, so let's take a look what is the EMU and the desired output for people who really are not familiar with that. The EMU is an inertial measurement unit and electronic device that measure and report a body-specific force, angular rate, and sometimes the orientation of the body using combination of accelerometer, gyroscope, and sometimes magnetometer. And this is according to Wikipedia. So this is, on the other hand, at the end of this one, so we are going to get from this EMU the Euler angle. So we are going to take any motion according to a fixed XYZ referential, and we would like to see what kind of angle we are going to move on. And this is very interesting, and it will be very quick to get. So as you can see in this picture, we are going to take the roll, yaw, and pitch from angle from each from the BNO055. Good. So let's take a look on the board that we are going to use. This is a very this is an AliExpress board, a very a cheap one. And there's something extremely important about the board that you have to take a look on it. So in the BNO itself, which is here in the middle, sorry, it's a little bit blurry, you can see that we do have the we need to have a special connection for the pins PS1 and PS0. For some board, this pin, which are here, PS1 and PS0, come directly connected to the ground. But in this board that I got, there is no connection, and some extra soldering are needed because we need to have the standard or fast I2C interface. We need to solder this one. If you leave it like that, it will be unknown state and you will not be able to perform the communication. Okay, so after the soldering, you should have this result where you can establish the communication. Okay, so last point is the communication that we are going to make. So, and you can see here, this is our STM32F1, and this is the communication we need. Unfortunately, for this time, we are not going to do the interrupt, even it's extremely interesting and very efficient to use, but just something very important. So there's a straightforward, the V in, the ground, and the clock, and the data one are quite simple, but there is an extra pin, which is the address. And this is a very important one. That's the one that specifies which address you are going to use. So if you put it high, and this is what we are going to do in our example, the address or the slave address will be the hexadecimal 29, and if you put it low and connect it to the ground, it will be the hexadecimal 28. Don't forget to not connect it. So you must connect to the pin, whatever high or low depends on your preference and the addresses that you do have with other devices. Okay, so I think we went through all the details that will help us to make our circuit work. Now we can start building the BNO TX and also RX. Sorry for the mistype. Okay, so here we are at our code. So we do have an empty main file, so nothing here for the moment. And we added the BNO drive C file and header file, so most of them almost empty, but I added just the I2C drive header, and also opened the I2C drive header where we need to add a function for receiving. So let's first start with a simple one, and the first one is the BNO address. So we do have an I2C function that is starting for the address, but better to make something dry where we are directly selecting the I2C address here. So the I2C address, where of course we need to select the which I2C are we are going to use. And as we said in the previous section, our address is 029 hexadecimal, and so if we are going to use the hexadecimal and for the address, we need to move it to the left by 1 bit, and this become the 0x or hexadecimal 52. Okay, and we still need to add the read write one, as this is just for the address, and it will be quite a very dry function to use later on. And this leads us quickly and really very quickly to the BNO transmit function. So for the transmit function, as usually, we have the I2C, which one we are going to use, I2C 1 or 2, and here the register and the data that we are going to use or to send. So quickly, so we do have the I2C start. So we are going to start, and here we select the I2C, so we put here which I2C we are going to use. Then we can use our new BNO05 address, which is a great one. So we just put here the I2C, and we put 0 as we are going to transmit or write some data. Then we can go and use the function, the I2C data here, and first we add the register. So this is almost, sorry, we put the I2C, which I2C, and then the register. So this is a very simple one and straightforward. We just have to copy. So after adding the register that we would like to use, we add the data. Last step and easy one. After sending the register and the data that we would like to change at the register, we just put the I2C stop and also which I2C we are going to use. Very easy and straightforward. That's wonderful, and that's really easy and simple. Then now we are going to create the BNO receive address. So we are going to read from the BNO, but before that we have to jump here and create our reading function. On this one, before we jump on the to the data sheet and take a look to the reference material actually. So usually we have to put the I2C, and then we will understand why we need to have some indicator for acknowledge or not acknowledge. So let's take a look to the reference manual for the STM32F1. Let's jump quickly to I2C, and we are not going first to the register, but going to the functional description. Let's go to the master mode, and inside the master mode we are going to the receive. And when we are going to receive, it's a very simple and clear way to do. So first of all, we need to wait. So first of all, we need to show that this is what we are going to do, and we need to put it as an acknowledge. Each time before receiving, we have to put the acknowledge so we can jump. So after putting the acknowledge, we have to wait until the receive bit get high or get to 1, and after that, when we read the register, we can go and have this register ready. So that's the only thing. But at the end we have to send, if this is our last one, we have send and not acknowledge. So we are going to create here a very simple function that will wait. So we'll keep putting the acknowledge until we got the final data that we need. So that's a very simple one, and let's take a look at it. So let's go here and let's remove this one and let's go for it. Okay, so first of all, we do have two I2C, so unfortunately we need to make that. So let's have a temporary file, a temporary variable, which is the chart that we are going to read, and let's put if I2C is equal to 1. Okay, so if it's equal to 1, and then we are changed to I2C equal to 2. So what we have to do first of all is to put the acknowledge one. So if we go here and we go, so we can go now to the part where we are reading about the registers. So we need to set this acknowledge register to high first. Okay, so that's the pin number 10, so the bit number 10. So let's put here. So first of all, I2C 1, and then so I2C 1 control register here 1 is or and equal to, as we said, it's a bit number number 10, so it's the 0 hexadecimal number 0400. This is the bit number 10. And so this is to say that we are going to receive the bit that is coming. After that, so we have to wait, and this is in the status register. Let's go for it. So if we go to status register 1 here, and this is the bit number 6 that we need to check. So let's go back. Okay, so let's go here while, and I2C 1, sorry, I2C 1 here is, so for the status register 1, and so we set the bit number 6, so the hexadecimal number 4 together, and this one is equal to 0. As far as we didn't really have this one coming, we still wait. Then so we just wait for it. So let's put this one like this, and we keep waiting. And then when we get it, then we can read the I2C, the direction register. So let's put here, is equal to the I2C1, and we put just dr here. And that's all, that's what we need. But before that, so if this is the last transaction we need to release. So what we can put is if ACK. So if we do have, let's add this variable here, so the acknowledge here, not acknowledge. So if this is equal to 1, means this is the last one. So let's put something here, and we can put here that we are going to send. So we can use exactly this one, means we would like to send a negative acknowledge, or we are not going to acknowledge, which is here and this one will be just the opposite of it. I hope this is the right one. No, where's this one? Yeah, so this is what we need to send, and quite very simple here. What we need to add now, we put an else here, a simple one, and let's copy this one, all of it, and put it like this, nice and easy. So if this is equal to 2, this one should become equal to 2, and let's change this one also to 2 here, and this one also is equal to 2, and that's all. We do have our code here ready. But last thing before we forget, we have to return the temp here, and that's all. So we do have the receive function ready to be used. So if we jump then to, and we need also to copy it, copy paste and add it here. Okay, so this one become perfect, and we can jump to this one here and start thinking about it. So for the BNO, now we need to take a look how the BNO have the reception procedure. So let's jump to the BNO datasheet, and let's go quickly to not a pin diagram. It's something, yeah, this is the one. You cannot miss it if you do have the BNO file. So first of all, you have to send the slave address with a write bit. So you put here 0. Then the register address that you would like to read. After that, you send again a start, or it's called a restart, with 1, which is read 1, plus after that you just keep reading the data. So as much as you put here, you can keep reading the data. And to close this communication, you have to send the non-acknowledge one. So that's all. It's quite simple. So first of all, we need to start as like we are going to reading the data, and after that we are going to writing the data, and then we just add the slave address with a reading bit. Okay, so let's jump to it. It's quite simple and straightforward, but what I have added here in this function is I'm adding the char here as a string. So as you can see, I'm not putting this function output as something, because I will be updating this string, and this is what I will be adding to my code. So this string will be, or this array will be fulfilled during the communication. Okay, so first of all I need to put int I. We will need to use it later on for a loop. And so I2C here, so I2C start, a simple one. Okay, and we need to specify as usual the I2C. I put this one here. After that we have to put the BNO address. You see how useful this one it is, and we are going to put I2C and putting 0 here as we are starting at the transmit mode. After that we have to put the I2C and data here, I2C data, something is getting wrong, and we can put here I2C as usual, and the register that we would like to read, as we have seen in the datasheet previously. So after that, so when we send this, we can have a restart again. We can copy this to 1 here, and we are going, instead of putting here 0, we start to putting here 1, means we are going to read the data. So we can start our loop 4, and not 4, and this is the data len that we would like to read. So for I equal to 0, then I less than, and what we are putting here, data len that we would like to use, -1. because for the first ones we are going just to read the data, but for the last one, so this is here I++, just let's finish this one. And each time inside this loop, what we are going to do is taking this string, so string of I here will be equal to I2C. This is the function that we created previously, so putting here Rx, and what we can add here in a very simple way, we put it here the I2C, so I2C, and we are going to choose between acknowledge and not acknowledge. To be better here, let's define acknowledge and not acknowledge, so let's put here define, so define, so ACK will be 0, where we are defining the n, so let's copy just this one and get it quite done quickly. So for this one, not acknowledge as 1 here, and that's all. So what we can do here, a very simple one, so we put the ACK here and we copy this one again, as because at the end of this loop, so we will have the same thing here, so the I will be equal to data len minus 1, and this is what we need, and we can put this one as not acknowledge to be read for the last time. Finally, and it's very easy, we just put I2C stop here, no, another start, and let's remove this one, stop, and I will just put I2C, and that's all. This is the two extremely core function. We try to be very dry on them, and we can jump to create the next level function and start the communication with the BNO. Now that we finish our transmit and receive function, we can jump and take a look on the initialization and also how to get data from the BNO055. So stay tuned. Okay, so now we do have the two last remaining function, and first of all, to initiate the BNO, there is not really a startup function or something to really provide a big change on it, but let's take a look on what I'm talking about here. So let's go here to the BNO, and most likely I'll be talking about how to get this data fusion. So if you would like to get the data, like the fusion data from the BNO, we need to send or transmit to change some specific register on that one. So if we go here and we go to the operation mode, what we would like to have is to have the absolute orientation of this mode, the NDOF. And to set up this mode, so if we go a little bit here, so the fusion mode, we need to set up a register. So which register? It's written here. If we go a little bit, this one, this is the part where it's explaining how it works. Let's try to check it here. I think configuration mode. Okay, so this is just the confusion about the sensor configuration. Yes, so if we would like to change this one, we have to go to a register that change that one. Let's check for it. So let's go, this is not that one that we need, but for the output, and we need to get the data. By the way, the data is set up here, and there is a function. If we go to the register list, if we go to the register here, description, and let's go to register map, and we go to the map of, yeah, let's almost here, this one, the operation mode. This is the register that we need, so let me take a look here. Operation mode, OPR mode. Okay, and if I go to previous, this is here the configuration, yeah, configuration mode. So to configure this one, let's go a little bit here, check it. Okay, not here, probably this is the one, yeah, exactly. So if we would like to set up this one, we have to set up this 1100 bytes for this register, for this operation mode register. However, there's a very important setup. We need to wait for 19 milliseconds, and this is extremely important, so the setup of the fusion register happen quite correctly. So we need to go to operation mode and change it to this number which is a C hexadecimal or 0C hexadecimal. So that's all. That's just what we need at that place. So what we can do, so let's here remove or uncomment the code, and we just go. So we will have each time to add the sysdig. So actually, let's confirm if I'm adding the sysdig library. Let me add the sysdig library directly to the BNO here. Okay, so we can have the sysdig init one, the sysdig init function. Okay, and this is to create the waiting time for later on. And for the I2C here, we are going to put the I2C init, and I'm going to use the I2C which is 2, but later on, but here it will be just I2C. And then what we are going to put, and this is very important again, so we have to add the I2C fast mode. We are going to use, because the BNO can be used on the fast mode too. Then we can transmit, so BNO TX, this one. So what we have to do here is to select which I2C we are going to use, and then as we have seen together, we need to change this operation mode register. So if I go here, the address of this register is the hexadecimal 3D, and we need to put here the operation mode of fusion mode, and this will be a 0C hexadecimal. So let's put it here. So the address of the register is the hexadecimal 3D, and the code that we would like to add, or the chain that we would like to operate, is the hexadecimal 0C. Okay, and that's all. Before that, let's add a delay, and let's put a delay of 50 milliseconds just in case. And that's all. That's the only thing that we need to do in the initialization. We have to know which register to change and the value to change, and we are in fusion mode, ready to work. Okay, so now let's start reading this Euler's angle. So to read them, let's go back again to this one, and the Euler angle are provided in the, let's check together here. You see this one, the pitch, the roll, and the heading. This is the Euler angle that we need, and we start from 1A, and we need to read to have 6 read for the register. So as you remember before, let's use our function here. So the void BNO Euler, and the output will be, so there's no output directly here, we are not returning nothing, but we are updating an array that we are receiving. So first of all, and there's something extremely important, we are going to have a short, which is the value that we are going to read each time, and we will put it equal to 0. Okay, so, and after that we do need a loop to read all these values. So what we are going to put, so integer for I, so equal to 0. Okay, and after that we are getting the value that we need. So let's work on this one. So let's first of all go and put the BNO receive. So let's BNO here, BNO receive here, and we are going to put here I2C as usual. And after that we are taking, as we said and we have seen together here, we need to start read from this address, the 1A address. So let's put here, this is the address that we would like to read, 1A, and we would like to read 6 times from this one. We are almost there, so because that's all the job. So what we have to do then, so now we have read this address. So let me check, something is not working right. So I2C 1A, of course we have to put, that's the mistake here. Let's add another array, let's call it Euler array, and we put it here like this, and we put 6 1 here. Okay, so we need to fulfill this array, so we put L here and we should be good now. Yeah, so this is the array that we are going to read and to fulfill for 6 times. Let's put a little bit more here just in case. Let's put 8 and we're good. So now we are going to get the data and put everything inside this angle. This is an array which is have the angles that we would like. So let's write this one, but there is an extremely important part that you have to understand, and if you do have a question for it, please let me know in the section, in the comment area. I'll be happy to go and discuss it with you. So for I equal to 0 and then I less than 3, so I less than 3, I plus plus. So what we are going to read from our end is like this. So for each register, so we need 3 angles. Why we are reading 6 registers? So if we go back here, because each of the registers have the low LSB and MSB1. So for both of them, it's a 16-bit value, and it's extremely important to know that it's a 16-bit value. So let's go back again, and so for each register, the value so that we are going to use is equal. So first of all, we are going to read the data from the Euler array. So this one, I multiply by 2 plus 1, so to read the MSB first. So let's put this one here, and after that value will be equal to value itself, and we are going to push it to the left by 8 bits. So this is how we are putting the MSB 1. Then value will be or equal to the Euler register, but here it just I multiply by 2. Okay, hope this is logical for you guys, and this is why we are putting like this. So this sorry, not plus but multiply, that's a big mistake. So if we do like this, so the first we read the MSB, we push the MSB to be from the first 8-bit of the 16-bit that we do have, and then we just add here the LSB ones. So now I would like to get back here why I have chosen the short variable. Short variable is a 16-bit variable, and it's also a signed one. So sometimes when this one goes to negative, if you choose here as an int, it will be more than 4000, the number will be quite bigger. But if you choose short, when you do have the negative number, it will be read as a -1. Okay, so last thing, and extremely important, we can put here angle of I, it will be equal to val. But unfortunately this is not enough. So let's go back again a little bit here, and let's go back to our fusion mode to show you something here. So we said, let's go previous again and jump here for this one. So let's put NDOF. Let's take a look here. Yeah, perfect. This is where I'm looking. And yes, for this one, just a moment, not the drop, not this one. The number what we are getting here, yeah, this is the one that we need to read here. So each 16 LSB is 1 degree. So what I'm going to do here is to divide this number by 16, so we will have directly the degree. So here, that's your preference, guys. You can choose a float number, but if you are concerned about the performance, I really advise you to keep the big number and move it to a more strong processing unit. So this is really a preference and the application that you are going to use. So just to let you know. And that's all. So here we do have our function to read the Euler angle and give you directly the angle directly. So now we finish this one, and let's go for the next step where there is all the fun and we can visualize the data. We just finished the BNO initialization and Euler angle, and now let's go to the most exciting part where we can read and visualize our data. We are finally getting at the main part, literally. So before jumping really to the code, let me give you a quick introduction to the circuit that we do have. So this is our, as usual, STM32F1. This is our BNO, the part profile purchased from China. And finally, this is the OLED that we have been using in the previous tutorial. So let's go back again to our part, okay, here. And we will need to add the libraries that we have been creating previously. So let's add the BNO. So include also the BNO. Let's copy it quickly. I'm a very slow writing person, unfortunately. So let's copy this one here. And also we need to include also the what else? The OLED function that we created, OLED drive.h. And also we need to add, this is the function that we created long time ago to use strings, and to have, for example, we will need here to convert some string to some integer to string. So this one is the help function. Okay. At the time I was lacking inspiration. I'm sorry guys, but this is the only name that I could come with. Good. So first of all, let's start with our BNO055 init. So for 0 here 55 or something is not sorry here. So the BNO55 sorry here init. Okay, what is this function name? Ah, of course, I didn't add these functions to the header. Yep, you see, sometimes it helps to see that things are not working, that we forgot to add here to the header two very extremely important functions. Okay, and here, so I should now 55, it should come up to have a init. Yep, and we are going to use I2C2. After that, we are going to initialize the OLED. So OLED init 64 here, and we are going also to put 2. They will be connected to the same one. Finally, so this is what we need to add just in case, OLED blank. Let's blank the OLED, clean it, maybe there's some issue or something. And we are going now to prepare our function, so we can put what we are going to show. So OLED message, we are going to use the OLED message. For those who doesn't know, this is a function that we add a screen in the OLED directly by specifying first the I2C, then the Y position, sorry, twice, and after that the X position here, which will be 10, and finally what text I would like to add. And for this one it will be the yaw, which is one of the angles, and like this. And after that we just do like this, and I will copy paste the same function and write it again and again, where here I'll put the row number 5 and this one row number 6, and here I'll be writing roll. I would like to see the roll, and after that this one pitch. Okay, that's wonderful. And let's jump now to the main code here in the loop. And first of all, I would like to read my my Euler angle. So let's go here and put some array. So it's a short array which we are going to put, so we call it angles, and there will be only three, so 3 variable, and we can go here and start reading them. So BNO055 Euler 1, and we are going to use the I2C function 2, and we are going to need angles here. Okay, so here with this one we are going to read all the data. So what we can do after that is quite simple. So we will need 3 other short number. So but short variable we don't need here, so we put short and we call it yaw and roll, and just over here, and pitch. Okay, so let's create quickly 3 definition here. So plus not the in the BNO here, and let's create this one. So define here the yaw with a big Y, and also define the roll. So because when we are going to read from the array itself, it will be 1, and finally define the pitch, putting 2 here. And we can use this one back here where we can read them, so we can put yaw will be equal to the angles. So this is some extra step that we are doing together, guys, so you can get a little bit more about the code just in case. So like this, and let's copy quickly, and we are going to change like this. So we get here the roll will be equal to roll here, where pitch will be equal to the pitch here. Okay, perfect. So now we could read all the function, all the value of the for the Euler angle. We can start writing them directly in the OLED. So what we can do, OLED message here first, and this is what we need to do, is to put same exactly. So we are going to use the I2C 2 position number 2, and then we are putting 50, and we are getting a little bit further because don't forget here, so this is 1 digit but it takes 5 position, and we would like to take a little bit space from that, and we are writing and putting an empty space here. This is to clear the previous one without really keeping any trace of it. After that, here where we are going to change and use our help function, and we are going to use into char function, and this is a function we create together, and this one will convert the row, and we need to put it in a sum array. Let's put it here. We call it, so it's a char, and we call it, for example, num, like this, and it will have 10 position just in case. Okay, not 0 but 10. Okay, brilliant. So we are putting the yaw number in the num array. After that, we just have to write this one again, quite very simple, and instead of putting the whole empty space that we are putting here, we just put this one like this. And that's all. That's really that we need to do, and repeat for the 3 other one. There is a way of optimization, but only for you guys just to take a look on this one. So for this one is 4, and this one is not yaw anymore, but we can put roll here, and after that here we put num. Very important space here. We need to remove all the data that is inside, and to use that there's strmt. So we need to empty each time the num array to not have any issue. And let's copy this one, otherwise we will have a problem here. And if we put here 4, so we change this one to the roll, and finally we can add the last one here, and in this one we put 6, and this one 6, and instead of having the roll we are putting the pitch, and that's all. That's the whole code that we need to have. And let's see, that should everything work properly. Let's save and build to see if there's okay, 0 error, 0 warning. Let's take a look then to the also to this one. Let's load and see how this is working. Okay, and let's run here. Okay, so we do have, unfortunately, everything is a 0, even I have a motion, so something is not really connected here. Let's zoom a bit. Okay, Okay, something is not red. So it's a good thing to check together to see if there is any debugging we can do. So let's start the debugging and take a look. So better here to start checking this angle here and to see what's going on. So I'm going to add this one to the watch list and to see what would be the value of my angle. So let's run and see what is going for the program. So let's go here. So all my angle are 0, so something is not working well on this one. So let's keep it run, and we need to go to the Euler function. So if I go here and let's put here and check what is, if I go to the local one and check Euler here, I see that everything is 0. So something is wrong in the Euler function. So let's remove this one and keep looking. So we have to see the Rx here. So the Rx here looks to be, let's check, and here reading, but Rx is using this function to read the data. So what we need to do is jump to this data and take a look here. It's still fresh. So we're going to use I2C2. Sometimes there's a forget. Yeah, of course. This is the mistake. This one should be I2C2. And let's take a look. So if I unbug here, let's go back here to this one. Let's make it a little bit smaller. We can do this one bigger here. Sorry, this one small actually. So let's make this one like this, one like this, and let's save everything. Save, and there's no error. And if we check here, we do have our angles. Fantastic. So let's try to zoom and to show you guys how this is working. So you can see here some angle. So let me move like this. You can see some angle moving, and this one too. So if I move the pitch, so I'm sorry, this is quite difficult to do this one. So the more up I'm making it, the more the angle of the pitch. And if I do like this, you can see the pitch decreasing. Where the roll also, if I do like this one, you can see the roll doing and increasing. But if I should do this, it will be negative. So the yaw is getting stabilized with time, but you can see that we do have, so if I move the yaw for the moment, no, but it takes a bit of time to get stabilized. So you can see together, guys, that how quickly and easily we could have this one working. So we do have our BNO connected with our OLED screen, and we do have a roll and pitch working perfectly. The Y takes a little bit of time, but it will be working at the end. Okay, so we have finished this tutorial, and I hope you enjoyed it, because this is quite a very nice one where we are using two tutorials together to get a really interesting output. I hope you enjoyed this one, and see you in the next episode. WeeW!